Hello everyone. In this video, we will discuss about conic section hyperbola. Let's define what is a hyperbola. A hyperbola is the set of all points in a plane such that the absolute difference of the distances between any of these points with two fixed points is a constant. The two fixed points are the foci of the hyperbola. So from this definition, if we get any point, let's say the point P on the hyperbola, and then if we get the distance of point P with the fixed point F1 here, and the distance of point P with the fixed point F sub 2 here, then the difference of the difference of the distances here, let's say if this is distance n and distance n, the absolute difference of these distances that is a constant. So when we say it's a constant, if we get another point, let's say the point Q on the hyperbola, if we get the distance of the point Q with the first fixed point and the distance of Q with the second fixed point, this difference here will be, or the absolute difference of the distances will also be equal to the absolute difference between M and M. Now, the midpoint of the segment joining the foci is the center of the hyperbola. So if we connect these two fixed points, which are the foci, by a line segment, the midpoint of this line segment will be the center of the hyperbola. The line that contains the two foci intersects the hyperbola at 2 points, which we call the vertices. So if we are going to draw a line passing through these two fixed points or passing through the foci, the line will actually intersect into the hyperbola through these points, which we call the vertices. Now, the said line here, the line passing through the foci and the vertices, and as well as the center, is called the transverse axis. Now, the conjugate axis is a line that passes through the center of the hyperbola and is perpendicular to the transverse axis. So this one here is considered as our conjugate axis. Now, for the parts of the hyperbola, or for some information about the hyperbola, we let C to be the center, or capital C to be the center of the hyperbola with coordinates h comma k. Now, just like in the ellipse, we call V sub 1 and V sub 2 as the vertices, F sub 1 and F sub 2 as the foci, and V sub 1 and V sub 2 as the co-vertices. Now, the distance between the center and one of the vertices is A. So if we have this vertex here and this is the center, the length of this line, or the distance between the vertex and the center, is small a. Now, the distance between the center and one of the foci is small c. So if this is one of the foci and this is the center, then the distance between these 2 points is small c. Now, the distance between the center and the co-vertex, one of the co-vertices, is small d. So in this particular hyperbola, we will call these points as the co-vertices. Now, in a hyperbola, the co-vertices are not on the hyperbola. So meaning those 2 points do not lie on the hyperbola. However, the distance between these co-vertices and the center is small d. Now, the relationship between A, B, and C in a hyperbola is C squared is equal to A squared plus B squared. Now, there's no restriction about whether A squared is higher than B squared or whether A squared is lower than B squared. So A squared can be higher, A squared can be lower, or A squared can be equal to B squared. Unlike in the ellipse, in the ellipse, A squared must always be greater than B squared. Now, in the next slide, we show the two types of a hyperbola. So the first graph here at the left side is called the left-right hyperbola, because the graphs are actually a combination of a parabola-like graph that opens to the left and to the right, And then the other one here at the right side, it is a or an up-down hyperbola. So in a hyperbola, we have here the center, and then we have the vertices of the hyperbola, and then we have the two fixed points or foci. The line joining them is the transverse axis. So if the hyperbola is a left-right hyperbola, then the transverse axis is horizontal. And then the conjugate axis is vertical. Now for the up-down hyperbola, this is the center, and then the vertices are above and below the center, and then the foci are above and below the center as well. And then the transverse axis is vertical, and the conjugate axis is horizontal. Now observe that in the hyperbola, we see two additional lines. So these two broken lines here no, are actually called the asymptotes of the hyperbola. So the asymptotes serves as a guide no, in graphing the hyperbola. So the hyperbola will just approach these asymptotes, but will never touch those asymptotes. Now, the general equation of the hyperbola is actually based on the general equation of the conic section, which is given as follows. And we know that this conic section is a hyperbola if A is not equal to C and A and C have different sides. So just like the other conic sections, the hyperbola also has a standard form. So the standard form of the equation of the hyperbola depends on its center, center capital C, which has the coordinates h comma k. And the standard form of the hyperbola is given as follows. So it is x minus h quantity square over a square minus the quantity of y minus k square over b square is equal to 1. So in here, since the term containing the variable x is positive, that means the transverse axis is horizontal. So which means that the hyperbola is a left-right hyperbola. Now, if the variable y is actually positive, then we call it an up-down hyperbola. So for the up-down hyperbola, the standard form is y minus k quantity square over a square minus the quantity of x minus h square over b square equals 1. So this is where the transverse axis is vertical. Now to graph a hyperbola, we follow the following steps. So we first write the equation in standard form in order for us to determine whether the hyperbola is a left-right hyperbola or an up-down hyperbola. Then afterwards, we will determine the center and determine the values of small a and small b. Then we plot the center C on the Cartesian plane, and then we use the value of small a to plot the vertices depending on the type of hyperbola. So if the hyperbola is a left-right hyperbola, that means if you plot the center C, then we have to move a units to the left and a units to the right to get the vertices. And then we are going to plot the co-vertices using the value of b depending on the type of hyperbola. So if the hyperbola is a left-right hyperbola, the co-vertices will be above and below the center. And then we solve for small c and then plot the foci depending on the type of hyperbola. So for the foci, we have to move small c units from the center going to the left and small c units to the right from the center. So these are the two fixed points or the foci. So observe now that the foci, vertices, and the center would lie on the same horizontal line for a left-right hyperbola. And then afterwards, we draw a rectangle where its sides contain the vertices and co-vertices as midpoints. So which means we're going to form a square using the vertices and co-vertices as midpoints. And then if we draw lines connecting the diagonals of these squares or of this square, these two lines serve as the asymptote or asymptotes of the hyperbola. Now, depending on the type of hyperbola, we draw two parabolic shaped graphs, each passing through the vertices. So if this is a left-right hyperbola and this is the vertex, then we draw a parabolic shaped graph opening to the left and a parabolic shaped graph opening to the right. So this is a left-right hyperbola. And then afterwards, we draw the transverse axis and the conjugate axis. So in this case, the transverse axis is horizontal and the conjugate axis is vertical. So let's have some examples of graphing a hyperbola. So let's consider the equation, the quantity of x minus 1 square over 4 minus the quantity of y plus 1 square over 9 is equal to 1. So in here, we see that the center has coordinates h equals 1 and k is equal to -1. And then, since the term containing x is positive, no, we will consider this as our a square. So a square equals 4, which indicates that a is equal to 2. And then this one is our b square, which is 9, which implies that b is equal to 3. So since the variable x here is the one that is positive or has the positive term, this means that the orientation of this hyperbola is a left-right hyperbola. Now, for the value of small c, we know that the formula says c square is equal to a square plus b square. And since a square is 4 and b square is 9, we get c square equals 13. So which indicates that c is equal to the square root of 13. So to graph, no, we from the origin, we move 1 unit going to the right and 1 unit going downward to plot the center of the hyperbola. Now, since the hyperbola is a left-right hyperbola, from the center, we're going to move 2 units to the left to get one of the vertices and 2 units to the right to get the second vertex. Now, since c is equal to square root of 13, this is approximately equal to 3 point something. So from the center, we move 3 point something units to get the first foci. And then from the center, 3 point something units to the right to get the second focus. And then we use b equals 3 as the distance between the center and the co-vertices. So from the center, we move 3 units above and 3 units below in order to get the co-vertices. And then afterwards, we form the square or rectangle, having the vertices and the co-vertices as midpoints, no, of the sides of the rectangle. And then we draw two lines passing through the diagonals or the corners, no, or the diagonal corners of the rectangle. So these are the asymptotes, no, of our hyperbola. And then since the hyperbola is a left-right hyperbola, no, from the vertex, no, or using the vertices, we draw two parabolic shaped graphs, one that opens to the left and one that opens to the right. So this is the graph of the following hyperbola here. Now, since we have asymptotes in the graph of the hyperbola, the asymptotes are actually obtained by equating the following and solving for y or and solving for the variable y. Or we can have y minus k square over a square equals x minus h square over b square. So this is how we solve the equations, and then we will get the following. So y is equal to b over a times x minus h plus a, and then we have y is equal to negative b over a times x minus h plus k. So in the previous example, now for the asymptotes here, the equation will be y is equal to b over a, so that's b over 2 times x minus h, which is 1, plus the value of k is -1. So this thing here can just be written as -1. And then the other one will be negative 3 over 2 times x minus 1, and then plus the value of k, which is minus 1. So these are the equations of the asymptotes of this particular hyperbola. Okay, next, for our next example, this time we're given with the general form of the equation of the hyperbola. So in order to graph this, we need to write this in standard form first. So in standard form, we shall group all those terms with y. So we get 9y squared minus 18y. And then we group all those terms with x. So since uh, 16x squared is negative, though we write the negative outside of the grouping symbol. So that would mean the negative 16x squared here becomes positive 16x squared inside the grouping, while the positive 32x here now will now become negative 32x. And then this constant will be transposed to the right hand side, so it gives us 151. And then we factor out 9, so we get y squared minus 2y, and then we add something for completing the square purposes, minus we factor 16 times the quantity of x squared minus 2x plus something for completing the square purposes, and then equals 151. Now, for the first grouping, since the coefficient in the middle term is negative 2, we will divide this by 2 and we get negative 1. And then we will be squaring negative 1. So that's going to be positive 1. But since this grouping is multiplied by 9, so 1 times 9 is 9. So we shall add 9 to the right side. And then for the second grouping here, since the middle term has coefficient negative 2, which is the same thing here, so we will add 1 here. But this value is multiplied by negative 16. So that's going to be minus 16, which means we're going to subtract 16 at the right hand side. So now factoring the following, we get 9 times y minus 1 quantity square minus 16 times the quantity of x minus 1 square is equal to 151 plus 9 is 160 minus 16 is 144. And then we divide both sides by 144. So we get y minus 1 square over 144 over 9 minus x minus 1 square over 144 over 16 equals 1. Now the 144 over 9 is actually 16. So this will be over 16 minus x minus 1 square over 144 over 16 is 9. And then this is equated to 1. So this is the standard form of the equation of this hyperbola. Now, since the variable y is positive, then this means that the hyperbola is an up-down hyperbola. So which means that a square is 4. A square is 16, which indicates that a is equal to 4. And then b square is 9, which indicates that b is equal to 3. And then the center of this hyperbola has coordinates h equals 1 and k equals 1. So the center is at 1 comma 1. Now for the value of c square is equal to a square plus b square. So since a square is 16, b square is 9, 16 plus 9 is 25. So this indicates that c is equal to square root of 25, which is 5. So now we plot the center. So from the origin, you move 1 unit to the right and 1 unit upward to plot the center. And since the hyperbola is an up-down hyperbola, we have to count a equals 4 units upward to get one of the vertices. And then from the center, we count 4 units downward to get the other vertex. And then, since b is equal to 3, from the center, we move 3 units to the left to get one of the co-vertices and 3 units to the right to get the second co-vertex. Now, for the focus, we move 5 units above and below from the center. So that's why we get the following focus and the following focus. And then, since we already have the vertices and the co-vertices, so we draw a rectangle wherein the sides of the rectangle would contain the vertices and co-vertices as midpoints, and then connecting the diagonal corners of the rectangle by a line would give us the asymptotes of the hyperbola. And then since this is an up-down hyperbola, we have to draw two parabolic shaped graphs. One is opening upward and one is opening downward. And both of these parabolic graphs will cross or will pass through the vertices. So this is the graph of the hyperbola having the following equation. Okay, now, let's have examples of finding equation of a hyperbola given some conditions. So first, let's find the general equation of the hyperbola having its center at -1, 3 and a vertex at -1, 5 and a focus at -1, 0. So it would help you if you will plot these points on the Cartesian plane. So in order to get the equation of a hyperbola, you should know first the orientation or the type of hyperbola, whether it is left, right, or an up-down hyperbola. You should also know the center. You should also know the values of A and B. So which among these can we obtain based on the following given information? So since the center is -1, 3, okay, we already have this information. And then since one of the vertices is given, the distance between the center and the vertex is A. So in this case, that's going to be A equals 2. And then the distance between the center and one of the foci is small c. So in this case, it's going to be c equals 3. So from the information from A equals 2 and C equals 3, we can easily get the value of D squared. So C squared is actually 9 equals A squared is 4 plus B squared. So if we transpose 4 to the other side, we get 5 equals B squared, which indicates that B is equal to positive square root of 5 or approximately 2 point something. Okay, so this B is equal to square root of 5. So this indicates that A square equals 4 and B square is equal to 5. Now for the orientation of the hyperbola, since the vertex occurs above the center, so that means the transverse axis is vertical. So which means that the orientation of this hyperbola is an up-down hyperbola. And the equation of the up-down hyperbola will be y minus a square over a square minus x minus h square over b square equals 1. So substituting the appropriate values coming from this information, we get y minus 3 square over a square, which is 4, minus the quantity of x minus h, which is -1. So this is going to be x plus 1 quantity square over b square is 5 equals 1. So since we're looking for the general equation, we will be multiplying this by the LCD, which is 20. And then we will be getting 5 times y minus 3 square minus 4 times x plus 1 quantity square equals 20. And then expanding these squares of the binomial, we will be getting y square minus 6y plus 9. But we have to multiply them by 5. So that's why we get 5y square minus 30 times y plus 45. And then the expansion of x plus 1 square will be x squared plus 2x plus 1. But we have to multiply them by -4. So that's going to be minus 4x squared minus 8x and then minus 4. And then the 20 here will be transposed to the left side. So we get minus 20 at the right side, at the left side. So combining like terms, we get 5y squared minus 4x squared minus 30 times y minus 8 times x. And then 45 minus 4 is 41 minus 20 is positive 21 equals 0. So this is the general equation of the hyperbola having the following conditions. Okay, next, this time, let's find the standard equation of the hyperbola having foci at 3, comma 1 and negative 9, comma 1. And the conjugate axis is of length 4. Now, I forgot to mention earlier that whenever we have the length of the conjugate axis, uh, that's going to be 2 times d. So length of conjugate axis is equal to 2 times d. Okay, so going back here, since the given points are the foci, okay, we can determine the center by getting the midpoint of these 2 points. So since this is a horizontal line segment, it's easy to determine the midpoint by just getting the distance of these 2 foci. So the distance of these 2 foci will be 9 plus 3 is 12. So divide by 2, that's going to be 6. So if we count 6 units to the right of this focus, we get the following as the midpoint. So this is the center. So the center is at x equals negative 3, y is equal to positive 1. And then the distance between the center and one of the foci is 6. So that's going to be c is equal to 6. So which means that c squared is equal to 36. Now the length of the conjugate axis is 4. So that means 2 times b is equal to 4. If we solve for b, we get b is equal to 2. And this would imply that b squared is equal to 4. Now to solve for a, since c squared is equal to a squared plus b squared, this is going to be 36 is equal to a squared plus b squared is 4. Transposing 4 to the other side, so we get 32 equals a squared. And this would imply that a is equal to the square root of 32 or 4 square root of 2. Okay, so if a is 4 square root of 2, that means a squared is positive 32. So now the orientation, so since the center and the foci belongs on the same horizontal line, that means the transverse axis is horizontal. So which means that the orientation is a left-right hyperbola. So if we have a left-right hyperbola, the equation will be x minus h squared over a squared minus y minus k squared over b squared is equal to 1. So thus, if we substitute the values of h, k, and a and b, we get x plus 3 squared over a squared, which is 32, minus y minus k, which is 1, quantity squared, over b squared, which is 4, equals 1. So this is the standard equation of the hyperbola that we're looking for in this problem. And then finally, let's find the standard equation of the hyperbola. This should be hyperbola with vertices at 3 comma 0 and negative 3 comma 0 and passing through the point 6 comma negative 3. So since the two vertices are given and they form a horizontal line segment, then we just get the center of this line segment and its center is at the origin. So this indicates that A is equal to 3. So center at 0, 0, A is equal to 3, which means that A squared is equal to 9. Okay, and then since uh, the line segment joining the vertices, the center, and the center is horizontal, this means that the hyperbola is a left-right hyperbola. So it should have x minus h squared over a squared minus y minus k squared over b squared equals 1. But since the center is at the origin, then we will only have x squared over a squared, which is 9, minus y squared over b squared equals 1. So now we need to solve for the value of b. So to do that, we're going to use the point P with coordinates 6 comma negative 3 because the hyperbola passes through this point. So we shall substitute 6 to x and substitute negative 3 to y. So in that case, we get 6 squared is 36. 36 divided by 9 is 4. Minus the y squared here is negative 3 squared, which is positive 9 over b squared equals 1. So if you multiply both sides by b squared, we get 4b squared minus 9 equals b squared. And then transposing b squared to the other side, we get 3b squared. And then the negative 9 will be transposed to the other side, you get positive 9 here. And then dividing both sides by 3, we get b squared is equal to 3. So this indicates that b is equal to square root of 3. So our equation will now be x squared over 9 minus y squared over b squared, which is 3, equals 1. And this is the equation or the standard equation of the hyperbola given the following conditions. So this ends our video for the hyperbola. So I hope that you learned something from graphing and identifying the properties and finding the equation of a hyperbola. So please do not forget to subscribe to my channel and thank you for listening.